Okay. Hello, everybody. Hi. Thank you for joining us for today's session. We are very pleased to have with us Gerard, my friend Gerard Teo from ID Architects. He's a director, and he's going to at ID Architects, and he's going to present on computational BIM for code compliance. Okay. So before I start on my sharing, as well as Gerard's sharing, I'll just have a brief overview of what my thoughts are on code compliance for computational BIM in Singapore. Okay, essentially, what we can do as a set of a framework for most firms, especially for mine. I have a small firm called Lian Architects, and what we do is that we will have a very basic framework to allow for quick massing studies for simple houses, residential houses, landed residential houses. And so, but to be applied on a bigger scale, I'm sure Gerard will have much more insightful practices. And just to touch on that, right, me and Gerard, we are both lecturers at the adjunct lecturers at the BCA Academy for the specialist diploma in computational BIM. And one of the students groups for this term, they are also developing something similar to what Gerard is going to share with you about, and that is using computational BIM generate a very quick set of design guidelines for their companies. And after they have generated that envelope control guideline, they will also integrate that with facade studies. And using these facade studies, they can generate sheet sets for their entire building. So in that sense, from feasibility studies to schematic design, even up to tender documentation stage, they have split it among the 3 group members. So this kind of integrated workflow is quite useful for all 3 of them to bring back to their respective companies when they finish up. Okay, so with regards to today's sharing, as I've mentioned earlier, Gerard will share with you on how he has applied computational BIM principles towards the avenue of code compliance. A lot of you will be very interested in this due to the upcoming CoreNet X system, whereby there is a lot of BIM related information and data sets that we will need to, we as both architects and engineers and technicians and BIM modeling specialists, we have to be aware of to apply to our own practices, workflows, and day-to-day work. Okay, so for now, I will hand over time to Gerard. What will happen after Gerard's sharing? We will have a 15-minute Q&A session. And so feel free to come up with your questions, but after Gerard has finished his sharing session. Okay. So for Gerard.
Yep. Hi. Okay. Thanks, Aloysius. So, okay. Before I start, everyone can see the screen and hear me, right?
Yes, I can. Yes, we can see and can hear.
Okay, great. Okay. So yeah, I think then I'll just jump into it. So yeah, today I'll share a bit more about how we use computational BIM, largely related to code compliance, but also some other restrictions such as design intents and stuff like that. So okay, a bit about myself. So my background is in architecture. So in architecture, in my work, I look a lot at data-driven, evidence-based design. So we really try and see, okay, how can we design a process rather than a single end result, and use the computational tools to really help us with that. So I also work in technology, in where we look at how we can apply these technologies to buildings. So computational design is definitely one of them. Other things would be, okay, how can we use AI, machine learning, VR, AR, and all these kind of complementary technologies to actually apply to construction. And like Aloysius mentioned, I also actually teach the computational design course with Aloysius in BCA Academy. I do work in education as well. So, okay, that's just a brief background on myself. So, okay, where I work is ID Architect. So, we are a mid-sized architecture firm founded in 1988. So, we've been around for 30 over years. So, this is just to give you, idea of the scale of projects that we do, and how we actually apply these tools. So, we are roughly probably the top 10 in Singapore architects in terms of project volume. So yeah, this is just a quick highlight of our journey. So the kind of projects we do are largely industrial. So we do have other areas as well, but mostly our focus is industrial. So you can see the different typologies of logistics, chemicals, semicon, and all that. So why this is because a lot of them are very process driven. So in our work as architects, we usually do go and have to have very in-depth understanding of the processes which they go through, and then apply our architectural knowledge to it. So a lot of the times these are very methodical, and they quite suited for application of a computational process. So these are some of the projects which we have completed. So okay, about different applications of computational design. So I think computational design is very a very large umbrella term that can encompass a lot of things. So here, what I've done is actually break it down into the different types of computational approaches, and where they can typically come in the workflow, in the project workflow. So what you see here is moving down the center is a typical workflow for a construction project. And on the left here, you see the different types of computational design that we can have, whether it's specific to one project, or generic tools that we can apply across several different projects. So definitely in the early stages, where it's a more conceptual study, we would be focusing on things like environmental studies, massing studies, very preliminary kind of things, into like generative design. How can we do test fits with the tools and all that? And as we go into design development, we are looking at okay, maybe minor optimization things. How can we actually design buildings that perform better, that fulfill their function better, and all that? And later on, it's really more of coordination side of things. So how can we take the data we already have and do more with it, generate submissions with it, and all that kind of stuff, and eventually into construction and post-construction. So then what you see on the right side is just a very rough comparison against, okay, more traditional, conventional approach, where it definitely provides a lot more productivity in the process and a lot more quality in the final end product. So, okay, I'll largely talk about this in two parts. So one will be a more technical approach where we use the tools in um, our submission preparations and stuff like that, which we largely use Dynamo for. And then I'll cover a more design kind of approach, which we typically tend to use Grasshopper more, but definitely a lot of interoperability nowadays. So it's not strictly that, but yeah, that's just how we've separated. So, okay, I think the applications of Dynamo, as according to the internet, is largely this. So here we see four main options. So first is automation. This is definitely the easiest to understand. This is really a efficiency thing, especially when it comes to repetitive or time-consuming tasks that we don't really need a human doing. We can use scripts, use tools to automate this. Certain access to the building information as well. So especially when this building information might be in different packages, it can be in natively in BIM, it could be in someone else's Excel sheet, your own Excel sheet, or a CAD file. So this can be a useful application as well. So generating design options as generative design, so you can explore a larger design space is also something. And analysis, so things through simulation, through running, weather simulations, we can take a look at building performance. So largely, all the applications would fall under these four areas. So okay, I'll start with automation first. So definitely documentation is a big candidate for this. Like you can see, typical projects have in excess of 200 sheets, almost 300 sheets. So when we are preparing our submissions to the different agencies, we would need to go and put a prefix in front of all of them. So even something simple like this, going through 200 sheets, it's going to take maybe a good half day or even a full day to just label all of them. And when we are preparing a submission set for another authority, then it's the whole task all over again. So what we have is just a quick script to add this prefix to the agency that we are submitting to and apply it across all sheets. So yeah, simple script, simple application, but definitely very valuable in terms of efficiency and time saved. Another one relating to this is renumbering sheets. So as the project goes on, sometimes we need to insert sheets into the whole documentation. And as you can see on the left, usually we append a number after that, but we rather not do this. So eventually when it comes to submission, it will be labeled, all the trailing numbers will have to be relabeled so they all run in order. So we also use a script to quickly do this and then extract all the numbers and renumber it on the right, so you can see that each one has its own unique sheet number. So about access. So here, what our goal is to generate a PDRP submission with the different elements color coded according to this Excel sheet. So we have an Excel template where we control our office standards, which, for each category, we have a specific color designed to reflect that. And then we've considered things like, okay, whether it clash, whether it's too hard to read and all that. So this is controlled by our technical department. And what we want to do is we actually want to apply this across all projects and be able to maintain that interoperability, where if we wanted to manipulate the master sheet, we could do that and eventually push it downstream into our current projects as well. So what happens here is we start with the Excel sheet as the control. We use Dynamo to extract all that information and then push it into Revit filters, so that every time we put a filter on the view, we know that we have that form of standardization that it will look the same across all projects as well. Of course, this lets us do it very quickly, so rather than setting one up for every project. And the advantage of using this over just a Revit template is that, like I mentioned before, it's more dynamic, that we can always change the master, and all previous projects can be easily updated as well. You don't have to actually import the template to and fro projects. So that's one use. So you can see here the before and after. So the before view on the left, where it's just a standard representation, and then on the right with each of them categorized by their buildability score. So, okay, that is roughly it for the technical side of things. So how do we use the tools in design? So as you can see here, we can use it on a lot of different levels. At initial high level, we can start with, okay, massing forms. Are we getting the right breakdowns of areas, the right overall GFA, whether, okay, our RAM sizing is good, and then later on down to a finer, more detailed level, where we are looking at things like facade cladding, where okay, whether we can minimize the number of unique panels, whether we can make sure that we fulfill all other criteria like visibility from the inside, not obstructing the windows and all that. And also another thing we use is VR. So the VR interface for BIM models. And what we do here is, because the computational approach is inherently very quantitative, we get to know, okay, all the figures about it, whether it works, costs, and all that. So what we do in VR is we actually look at the qualitative side of it. So, okay, with this design, what's the aesthetic of it? Does it look good on a building? Is it well integrated with the design and stuff like that? Or, even something simple as does the client like it? So that's what we do. And we also look at application for fabrication. So typically, in the conventional design process, we would work with the manufacturers and contractors to fabricate something. So this process actually requires a lot of back and forth. You can see from the diagram, every step of the way, if there are changes required, we need to actually go back to the start of the loop. They would come back to us, get approval again before they can move on to fabrication. So instead, because we already have all the detailed information that is required, we would understand the manufacturer's requirements. So, okay, what kind of equipment they are using, what are the limitations of this equipment, other things like, okay, transportation, is that issue, whether there are any structural issues, cost and all that. And we would integrate it into our generative script. So then this generative script would be able to include all their concerns and result in a much more streamlined process, where there's not so much back and forth, and we know that, okay, whatever we design would comply to all these other requirements that these other stakeholders in the project would have. Okay. So, all right, I think that is roughly it for a quick overview. I think to illustrate some of these points, I'll show you some examples as well. Okay, green is still good, right? Otherwise, it's okay, right? You can see the Rhino graph on the screen, right?
Yes, I can see. It's just a bit laggy. But
Sorry.
yeah, I can see that you are rotating, you're orbiting around your
Yeah.
Rhino
Okay. Okay.
workspace.
Now, just to make sure that the screen sharing swap the screen. So okay. Yeah.
Okay.
Yeah. Okay. Great. Thanks. So okay. Yeah. What we see here is actually Rhino and Grasshopper. So in the background in Rhino, what we see is a topo surface. So here, actually, there was a very specific requirement quote from overseas that restricted the slope of the topo that you could build on. So anything that was past a certain degree, you cannot build on. So that's how we initially developed this script. So here, what we did is we took the survey points and then we um, converted into a mesh so that it would be a surface rather than just a bunch of points. So you can see it's actually a relatively uneven kind of surface. So how the script works is now that it's reading 0, it's actually highlighting all these areas in blue that are perfectly flat on site. So as I increase this, then you can see that it's highlighting more and more areas. So here it will be highlighting all the areas on site that are 23 degrees or less slope. So then it will give us a total here. So all we have to do is set this to the code requirement and then check whether, okay, we have enough total buildable area and then proceed with that. So to make a more informed decision there. But of course, we would want to try and take it further rather than just complying. We want to see if we can optimize a bit more, if we can minimize cut and fill, we can minimize retaining wall works and all that kind of thing. So once we actually know the buildable area that we require, say if we needed, something like 10,000 meters square, we can just very quickly, zoom into, okay, if this is close enough, then these are probably the areas that we want to look at siting the building first rather than other areas on site to just minimize costs where not absolutely necessary. So this is definitely something that we can use over and over again for different projects. So once we develop it, as long as we have a mesh, so whether it's from scanning or from survey, we can actually just implement it here. So of course, the next few steps from here would be to input a platform level for our building footprint and actually do the calculations of net cut and fill, whether we are net positive, net negative, or are we as close to net zero as possible. So okay. Okay, so this is another tool that I think is pretty straightforward in how it works, but definitely also has a lot of utility for us. So this one has to deal with parking lots. So what we've done is we've actually extracted all the information from that LTA handbook on parking, lot size, driveway width, and all that, and then we've created a script to generate these car park lots for us. So I think a lot of our approach is trying to be a bit more preventive rather than corrective. So things like, okay, checking after the fact is done, I think that is more on the authority side to do. For us, I think our focus, what we really want to try to achieve is to be more preventive so that when we actually generating it, we are already within the guidelines uh, and we know that, okay, whatever it is compliant. So here we put in the whole bunch of um, dimensions that are required for lot sizes. So your typical lots, your parallel lots, and all that. And really, what we want the script to do is just to tell us, okay, within this boundary, if we were to use this for car park, how many can we generate? And then this will just quickly generate it for us. So we know that, okay, there are more than one ways to populate parking lots in here. So we have controls here also that let us, flip the parameter lots to parallel parking as well and get a quick readout, or how we want our internal lots aligned as well, or even whether we want any spacing between the lots, or we want to try and squeeze them together to get the maximum amount of lots. So all these things can be achieved by this script already, and we can even quickly test a relatively irregular boundary and have the inside lots aligned this way as well. So you can see this also adds a lot to efficiency. One more thing that I would mention here is you can see here there are some lots that are highlighted in red, which don't actually count to the total lot number. So why we actually highlight this is because we know that they encroach onto the driveway by a certain amount, which we can control. So anything that's just going a little bit into the driveway, we are writing the script to say, okay, show them, but don't actually count them in our total. So this is because if we were actually short of maybe one lot, then we will be looking at potential waiver case for all these that would encroach a bit, rather than we need to really have to do a whole new configuration again. So I think this is definitely the advantage of having someone with the domain expertise to code these scripts rather than someone who's just a programmer, who's agnostic programmer, not really into the industry, to try and understand this and code this, because it affects the way that we code it for use as well. How do we envision the end user using this is also something that we are considering when we are creating the scripts. Okay, so okay, so another component that we generate fairly regularly through our projects are RAMs. So RAMs are quite ideal for this parametric approach because they only differ in input parameters. So things like a heavy vehicle RAM, car RAM, even pedestrian RAMs are actually all slopes that conform to certain different sets of rules. So different maximum gradients, different widths, different turning radius, and all that. So here we actually have that, where we have a typical RAM. We can shift where do we want it to connect to a central driveway or a car park entrance or something like that. We can control the size of it as well with the slope. So we've in this case we've hard coded it to stop at the requirements for heavy vehicles. So what it's doing is it's generating a RAM and then giving us the headroom feedback after that. So we know that after a structural offset, we definitely have enough headroom clearance for our vehicle to drive up. So we can manipulate all this individually, whether it's more floors, less floors, kind of thing. Whether there's a floor, first floor offset, so double, triple volume. So you can see the tail of the RAM actually adjusting for that. But what we can do here is we can try and take it a step further and introduce a bit of automation. So we can use an evolutionary solver here to start helping us manipulate those input parameters. So here you can see it's actually adjusting those parameters on its own. It's not doing this entirely randomly. So what we've done is we specified an optimal end case for it. We are saying, okay, in this case, we want to make the footprint as small as possible because we don't want to build a RAM that is bigger than necessary. We want to minimize the CFA. But at the same time, we don't want the smallest RAM that is very steep, that becomes very hard to drive up. So we are balancing it against that as well. And we know as a strategy, eventually in the void in the middle of the RAM, we want to put an M&E room of certain ratio of sides of a certain size. So we've put all of this into the solver and told it to solve for us. So you can see that actually this is not that difficult a problem for the solver. Just by matching the parameters, it starts to learn a little bit that, okay, the smaller RAMs are definitely performing better. The ones that are very big don't score very well. So the narrowing down process actually works pretty quickly. So yeah, for a human to solve this would be time consuming. So here, it will produce something like a few 100,000 kind of results, which of course we are not really interested in all of them. We are more interested in maybe okay the top 10, the top 15 results, and okay which one would be best for our design intent. So yeah. Okay. Okay, so another compliance thing is definitely fire escape. So this one is definitely something that would be very common that people would try and apply it to. So here we have your typical handbook example where you have a U-shaped building. So how we have it set up, right, is we can actually just select a point and plug it in to the script, and it will actually calculate the coverage for us. So you can see a one-way and two-way coverage. So as we move this point around, we are able to see, okay, just by the color. So this would be, of course, simulating where the exit actually would be. Just by the color, whether actually we have full coverage or not, or we have areas that are not covered, like in this corner. So we can also test it for multiple shape, right, where we can see there, okay, which area is not covered. So here, whether they overlap and how much coverage is in the floor. So definitely a few ways to manipulate it, whether we manipulate the exit points or we change the building footprint to see okay what these changes would affect on. So typically how we would do this is not so manual because I don't think we really design footprints like that, but we would extract all the information and quickly run the script to analyze okay whether we have coverage on it. So that would look something like this, where we've already uh, tentatively placed our exit points, and we've input information about the building where uh, we can see okay where there are certain gaps in the escape distances, especially when we start putting internal rackings like this. So we can see, okay, definitely we potentially need to add another exit here to cover this area where there's rackings. If not, the most remote points not covered by our exit. So yeah, stuff like that. Um, so okay, this one was start design for just now the building that we saw. So the challenge here was we wanted to have windows behind and then have this timber cladding which had abstract wood grain kind of pattern on it. But the issue we were facing is when we had our artists generate this kind of pattern, a lot of the windows behind will be becoming obscured. So that would kind of defeat the purpose. So what we did here is we actually worked the other way, where we determine window density, window placement, and then we would try and fit a pattern around it. So here would be a vertical density, so how many floors it will cover. So whether less or more. So you can see the vertical density of the windows adjusting, and the pattern would just adjust to fit the requirement as well. So these white squares are actually the windows, and then you see a pattern on top of it. Then horizontal density, so how many columns based on the structural grid. So whether it will be less or more. And so what we did is within that, we want to be able to have options as well. So we made it able to generate infinite amount of options, like in case just the client said, okay, we don't really like this, or they are not so sure about aesthetic. So using the same input parameters, we are able to shuffle the result and then come up with just aesthetically different results. So further to this, we actually tried to extend the capability of the script a bit more, where we would say, okay, can we look at how these panels are being cut out? And you can see here that actually now that we've color coded them, all those panels with the same color are actually the same panel size. So this one that looks like, TV pattern kind of thing is definitely not so good. We would want to see, okay, is there maybe an option that has less different types, so big patches of the same color of panel, yeah, maybe something like this. So then we want to look at, okay, how are we actually going to fabricate that as well? And we can see here that here we just quickly schedule all of them out, and we can see, okay, how many unique pieces are there and how many of each piece as well. So in doing this, we can make a more informed design. Right. Okay. Show maybe one more example. So okay, this one is more example on an urban scale. So in this case, the code compliance is not so much building code, but more of our design guidelines. So things like, okay, how much GFA do we want to generate in this area? How do we want the breakdown GFA to be? So how much residential, how much commercial, and so on and so forth. We want to have a green area that's open to sky. We want to make sure that proximity of the residential and the waterfronts is a certain distance. We want to make sure that every unit in the residential gets a decent view. So all these constraints and design intents, we've actually extracted them, translated them into geometrical terms. So for example, okay, how do we maximize the number of residential units with a waterfront view? We look at, okay, the angle of the facade of the buildings towards the waterfront views, and the more acute it is, that means the less view they have. The wider the angle, the better the view. So we're using these kind of sort of generalizations to codify our design intents in geometrical terms. So once we have all that, we can actually run the script. And have it generate a scenario for us. So yeah, we can see there, okay, we also included things like we wanted the blocks to terrace down towards the waterfront, to split the typology, something like that. So this is representing the green open area, and yeah, so this is one potential scheme. If we actually wanted to try different options, we can run the script again and have it generate a different option. So definitely a few ways to evaluate this. One would be just looking at it. Okay, is this something we're thinking of, or it's very far off from what we're imagining? or we can then run evaluation on top of it as well. So, okay, how far are the block-to-block proximities? Are they good enough for us, or do we feel some of them are too close? How um, how close are all of the blocks to each of the infrastructure exits, to the nearest parking structure, to the nearest MRT exit, and all that kind of things. So we can then evaluate, okay, which option is potentially better. Other things we can do is we can also change the input parameters to say, okay, maybe for example, if we wanted to shift this green communal area, say it's somewhere here instead. So now it's completely obscured by these blocks, right? And then we want to see, okay, if it's in this area, what kind of solution can we generate? So you can see it quickly generates an option where, okay, we have that area clear, and somewhere there the blocks will try and shift away from it. So this definitely helps us explore a much larger design space, because in a traditional process, to just generate one design take at least a few days to consider everything, calculate GFA, make sure the breakdown's right. So it's not not very optimal to explore many schemes. It's much more realistic to focus on one and make sure everything is right. So yeah, by doing this, it lets us really look at more design options. So yeah. Okay, I think that's about all I have. So yeah, thanks.
Oh, thank you, Gerard. Yes, very good breadth of topics that you have shared with us. I'm very glad that I gave you more time. So the thing is that, yeah, I find it very interesting. And so now it's a Q&A, but because your stuff is so interesting, I just take the first opportunity to ask.
Sure.
I've got a few questions, but the first one, right, which I think a lot of people who are here will be interested to know, is because most of us that are inside this like this lunch webinar are already working practitioners, and then um, have used Revit or other BIM software quite often, but it's still waiting for that next for that step to go into computational BIM that you have shared by using automation as well as optimization. Examples like, for example, the sheets, prefixes, right? So maybe some of people who are here have already started doing that, but to take the next step to go to optimization of generating the RAMs, all of this, right? And the fact that, like, for example, ID Architects, I saw from your overview, it started in 1988. So probably the company itself was using the older software, maybe started off with CAD, then slowly Revit, then maybe SketchUp, all this. How did you manage to spearhead this movement in your company to adopt this kind of new technologies? Because I think a lot of small and medium enterprises out there, they are caught in the whole practice of the clients and developers having a lot of demands. They wouldn't have this sunk cost time into developing this now. Just want you to maybe share with us your experience on that.
Okay, sure. So I think definitely, like you said, the first few applications benefit from being very pragmatic ones. Of course, I think a lot of people who pick up the computational tools are looking at very formalistic approach, like, okay, how do we make the next Zaha building, and things like that. But as you can see, the tools can do a lot more than that. And it's definitely better to start from the pragmatic side because it lets all your stakeholders see, okay, there's actually value in this. I think there's definitely a misunderstanding that we only use these tools when we want to do complex forms. But even with the most basic forms, we can still optimize within there. And these are good examples to show them, hey, actually, the tools are not that frivolous. They are very grounded, very utility based as well. And it would definitely be um, how you apply them to the interests of the stakeholders. So, of course, internally, everyone wants to be more efficient, work faster. So that is one set of things. But when you're looking at the client's point of view, especially from the developer side, they'll be like, okay, how can we optimize costs? How can we, run the project smoother? How can we not overrun our cost estimates and all that? So by looking at their problems, then I guess that would inform you on how to direct your scripts. Of course, if the issue you're looking at is, okay, how do I create fantastic form for a building, then there's also something that the tools potentially could do. Yeah.
Okay. Yeah, that will be very useful for a lot of the attendees today to try to push for this.
Mhm.
I also want to check with you, right? Because just now you raised a very important point about the car park when you were developing this system,
Mhm.
where you talk about if this was to be done by like a software programmer versus an
Mm.
architect already knows what it should be compliant and how to really process this information to go
Mhm.
into to codify it, so to say,
Yeah.
within Grasshopper itself. So,
Mhm.
how would you think? Okay, there's many aspects to this part in architectural
Mhm.
practice. Firstly, as a stakeholder, like the director, like the
Mhm.
CEO of IDA,
Mhm.
I have to like take away the time of an architect to invest into this, to develop
Mhm.
this
Mhm.
system.
Mhm. Yep.
So like how, it's again like a discourse of the dollars and cents of the architectural
Mm.
practice.
Mhm.
Then
Mhm.
the second thing is also, where do you find this architect who practices and yet knows how to codify?
Yes. Yes.
That-
Right. Right.
that's also another aspect that it will be good for you to share with attendees so that they can bring back to their firms to really spread this word.
Okay, yeah. I mean, I definitely don't really have an answer. Like, where do you find an architect with this skill set? I mean, like yourself, a lot of them are driven by interest and, how can we just do things better?
Hmm.
Of course, one way, one place to look would be, yeah, the people who have been through the BCA course. At least they would have the fundamentals of computational skill. I think probably another impression that we have is that, hey, because this involves programming and coding and all that, so the best guy is the programmer. But I think what we don't realize that not all programmers are going to be able to do this. This is even a subset between there. A lot of programmers won't be able to handle geometry. Like, how to code for geometry is also another specific skill, and then how to code using geometry in a construction environment is even more niche. So, yeah, definitely the answer is not just, okay, we get a programmer, he should be able to do all these things. Certain things like, okay, sheet renumbering, all that one doesn't require any specific knowledge. But like the car park example, yeah, just to go and read the handbook and understand what LTA is saying, yeah, you need someone who understands that and then be able to code for it rather than, okay, I just, know how to write script. It's not terribly useful also. Yeah.
Okay, good. So we are opening up the questions to the floor. Any questions?
Yes. Moonway. I'm Moonway from DA.
Hi, Wei. Yes.
Yes. Actually, I'm hidden. So actually, I have one question. So the question is actually on the code compliance. How do you actually integrate different agency's code compliance requirements into your script, or you don't do that. The question is, what is the strategy to integrate different code compliances and requirements into your code?
Okay. Okay. So currently, we definitely develop them separately because, like the authorities' requirements are also drastically different. So there's no way we could do everything is in one. But how we integrate them is we make use of the interoperability tool so that maybe once we generate things like RAM, car park, we stream them all into the same BIM model for documentation, so that's where it usually gets compiled. Yeah.
I see. So is there the script is being developed separately. So what if there's actually a mega Excel that contains different scripts? Will that help?
I mean, there's more of a corner X scope from the way you see it, to be all-encompassing kind of thing. Yeah, I think corner X is probably a better solution than us, trying to develop something on our end that can fulfill all the authorities' requirements.
I see. Okay, so which means what you're mentioning is if there's actually a mega Excel, so it might help to integrate the references of among all different agencies' requirements are much more easier because there's actually an Excel that provides the source of the codes.
Like those numerical based codes, is it?
Yes, those that can be quantifiable.
Yeah. That is just it's a back-end resource that we can refer to, but probably that's the easy part of doing it, compiling that. But how to take these values and do something with them to check whether it complies, the big thing.
Okay, thank you.
Yeah.
Okay.
Can I ask a
Any
question?
other question? Yeah.
Hello.
Okay.
Yes.
Feel free.
Hi,
Yeah,
hi.
I'd like to. You go first.
Oh, sorry. Oh, hi. Thank you for the presentation. I think I find it very interesting, and I also see some actually you already resolved some of the issues that the professional programmer has been working on. I just like to ask you a little bit about the part that you are mentioning about the importing Excel to Revit. Can you elaborate a little bit, because I try to understand what kind of elements you are trying to do. I mean, you have successfully imported into Revit from Excel.
Okay. So actually, we do extract a lot of different information from Excel because a lot of info comes to us in Excel as well. So, but in this case, today's example, what I was showing was our BDIP template. So when we submit, we wanted to have these different colors showing all the different elements, the different LSA elements. So we took that template, extracted the names, extracted the colors, and then pushed them into the existing Revit filters so that we could then prepare our submissions like that.
I see. So it's more for for the example today is more for graphic presentation. Is that what you're trying?
Yes, that is right. So this one is for graphic presentation, but we've definitely extracted things like Kobe information, like site information. These things sometimes come to us in Excel sheets as well, and we want to integrate it in the BIM model. So that would be more like filling in parameter fields. So if we had fire rating for all the doors that need to come in, we can actually push it in through this Dynamo as well.
So yeah, so actually I'm interested in still parameter, but you are saying that you are able to import parameters through using Dynamo. Is that correct?
Yes, that's right.
So you're able to, like, for example, for how many items or how many objects you can put in one go?
Actually, if we are talking about mostly like string, so like text and numbers, right? It's computationally not very heavy. So yeah, even 1,000 items in a project, it shouldn't be a big issue.
Okay, so so you are able to like import parameters for different objects, like for example, doors and walls at the same time?
Yes, yes. The
Okay.
difficulty comes when they affect something like if we are importing offset values, then because backend it has to recalculate every time we change the position or something, so that can get very heavy very fast. But we are just writing text parameter fields, right? Yeah, it's quite simple to do.
I see. Okay, okay, thank you.
Yeah, sure.
Hi, I have a question.
Yeah.
Okay, so last time I used to do computational design also for infrastructure, whereby back then I had my one of my modelers did alignment and then she did it wrongly, so I had to move all the like track sleepers in a tunnel. So I did use computational design for that. But my question is more like so for example, you've done all of this like renaming the sheets and all. What are your thoughts on automatically generating piles and diaphragm walls? Maybe for piles, maybe from the information you can extract from Excel sheet using Dynamo, and for diaphragm walls, how? Whereby okay, you only have a cat file. Is that possible?
Yeah, it's definitely possible. Okay, so I think for something like that where everything is very rule based, everything is okay, very procedural, it is definitely possible to do. So okay, if you could probably say take this cat file and you can write out the instructions, just verbally in text, not in code yet, then it's definitely a viable candidate to be automated in code. The concern there would be the amount of data of info that you could extract from your Excel and from your CAD file. For example, your CAD file, does it have everything separated properly into layers? Within those layers, the lines all clean, things that are supposed to connect will connect, things that are supposed to be closed loops are closed loops. So as long as your data source is rich enough, then yeah, I think it's definitely a potential candidate that could be automated.
Okay, okay. May I know, is it prevalent in your company with regards to this kind of exercises or this kind of processes whereby you are automatically generating graphical elements besides from ramps and for your car parks, or maybe other elements?
Yes, we usually when things are very rule based, and we need once the threshold is once you do it a few times per project and we can generate enough time savings, yes, we would potentially have a script for it already.
Okay, thank you.
Yep.
Okay, any further questions on the floor? Oh, okay. There's one question from Bob. A lot of the script seems good to kickstart the design process. Are there any that you have developed for checking, say, before submission?
Okay. Right. So for us, usually no, because like I mentioned, we as industry side people, we prefer more preventive rather than corrective measures. So we don't want to go until the end, then we realize, hey, something is wrong and we have to correct it. We rather from the start we are already within the guidelines. We know that whatever we generate here is correct, and eventually we will hand it over to the authorities. So from our perspective, the checking side is more authorities to check. We are confident that okay, what we generate is compliant, and then we leave the checking to authority side with corner X and whatnot.
Oh. Any more questions? Okay, so if there's no questions, it's just 1 o'clock now. So we will conclude today's session. So thank you all for joining us. Thank you especially to Gerard. To all of you, please take note that these sessions are always going to be uploaded onto the Practice Team YouTube channel. So feel free to come back to listen to Gerard's slides again, and also spread to all of your friends who may be interested, because I think what he has brought upon is a very, very interesting and a kickstarter to practices in Singapore and even in the region, because we really need to have this kind of adoption throughout different aspects of the workflow in our architectural practices or even engineering practices, to say, because it's not just about automation, it's also about optimization and design as well. Okay, so thank you all. Hope to see you all next month. Thank you, Gerard.
Okay, sure.
Okay.
Thank you. Thank you. Thank you, Gerard. Thank you,
Thank you,
everyone.
everyone.
Bye.
Okay.
Everyone.
Okay.
Thank you. Bye.